Perfect. Perfect. Thank
Yeah,
you.
perfect. Hey, welcome everybody.
Welcome,
So this is our
everybody.
fun 61C still.
Woo!
We haven't started a different class yet. All right. Um,
All right.
a few things that we wanted to discuss today, and we're going to go relatively quickly into that. Look, my control works. This, we're using this app, and it works. They have a release every other week, and it works better and better. So by the end of the semester, we will be spectacular.
We might be out of beta. We might actually be out of beta by that first
Yeah,
time. Go ahead. Go ahead.
yeah. Anyway, so we are in week 3 now. What is happening is we have covered floating point. It's very fun. So Dan apparently had a lot of fun recording that lecture
Yeah,
too.
it was great. It was wonderful. It took 3 days of my weekend to do one 1 hour of lecture. It normally would have taken me 50 minutes to give the lecture. I would have grabbed my slides, given it 3 solid days to make the lecture. So I hope you folks appreciate it. But it's a lot of fun. It's a lot of fun putting these archival materials together. And I want to check in to see if all of you have enjoyed the new clicker questions. We made some mistake the first time. We had too many. We had 11, and there was some confusion. So we've reduced them down to hopefully being a much more manageable set of questions. And each question, the goal is to teach you something. Not did you watch minute 13, but did you teach you something? So we're actually in a way writing exam questions into clicker questions. So in a way, we're trying to do this to, again, receive that feedback and always try to improve. So thank you for that good feedback, folks.
Yeah, we don't have those questions. What size shoes does Dan wear?
On my third juggling dig, did he drop it? Did he wink? No, none of that's going on. So it's very good.
Yeah. And RISC-V is in. The first part, very simple introduction to RISC-V is in. I managed to record the next lecture worked already. So I'll try to post that relatively early along with a bunch of RISC-V stuff by the weekend. I know you're probably focused on Quest at the moment, but it'd be really important to follow everything that is going on with RISC-V because we really need to get going with those labs next week.
Yeah, and we'll this is kind of a switchover week. It is important that this week's material is not covered on, so we're not covering float or RISC-V for the Quest this weekend, but we're certainly going to be needing it very soon because there's a project coming up and there's more labs and project after that. So we'll do that as well. And we are recording this. We didn't record it last week, and we got that record button. We smashed the record button, as the kids say. So we've got that rolling for that. And again, thank you for all the support and all the great suggestions on Piazza for how to improve.
Good job, Dan, on smashing that record button. So going into jumping into the news, here is a chip that got a lot of press over the summer. It was announced, I think, in June, and then a little more details came out in a conference that was held in August. It is Nvidia's new GPU, but this, they call it a graphics processing unit, but this is pretty much everything other than a graphics computing unit. So it is a domain-specific machine, however, that accelerates multiple domains where we care about linear algebra. So it's a very expensive chip. It is a big die, and they do want to get. It's a foundation of multiple different products that Nvidia will be offering. They are taunting about its performance, and here are a few things that they're talking about. They're talking about their floating point performance. That's why we picked this news for this week. And what is interesting there, they've introduced a brand new floating point format that is TF32. Now, Dan has mentioned in the lecture that there is IEEE 754 standard. There are few other different standards that people who did not think floating point standard from IEEE is going to serve them well, so they invented their own. So we got bfloat 16 that more than just Google has adopted. It is now adopted by Intel's processors. But Nvidia has pushed something completely new. They got TF32. Someone would think that's some kind of a 32-point floating point standard, but no, it's a 19-bit floating point standard.
And you're thinking 19 bits.
Yeah, and you start thinking about, you know, British machines of the 70s with, you know, 14 bits and 13 bits.
I got a 35-bit int. How about that? Anybody want a 35-bit int? I mean, what are we up to here? It's ridiculous.
Yeah, they have good reasons. It's worth reading about their blog posts why they want to do this. I mean, it basically took two parts from the, you know, appropriate mantissas and exponents from bfloat and FP16, or from and made it smaller. So they're trying to save compute power, but they're wasting quite a bit of data storage over there, and that's kind of important. We'll see how this plays out. This is not the first one. There was a flex point that Nirvana introduced a few years ago, and that seems to be gone. I mean, it lasted for about a year. They had it in one generation of products and gave up on that. But NVIDIA claims spectacular performance in this. I am going to flip through a couple of these slides. And you know, one of the first things that they're showing, they're not talking about graphics here. They're talking about accelerating high performance computing. And they're showing best-in-class numbers that are, oh, look at this is fun. These bars are green in the presentation, but what has happened is...
it's the background. It's the Campanile. It's the Campanile in the background.
It's a Campanile. Very good.
That's brilliant.
There is a Berkeley benchmark on the bottom.
Oh, that's beautiful. Well, what's anyway, better than the Campanile for a Berkeley benchmark? That's
perfect. Yeah. So and one of the big things that, you know, what sells a lot of these NVIDIA chips is machine learning acceleration. So accelerating different kinds of machine learning workloads. And what they've shown here is that they got some really nice performance for a single chip, for a single GPU. You know, tends to beat everything else. Why they talk about that? Because these pods that Google uses for their tensor processing units that we have shown in the first lecture do still beat collections of GPUs by a wide margin. A few things that we have seen before is I think we have shown this in the lecture, and it better get out of this slide over here. So we have FP32, which is an IEEE standard. We have FP16, which is a half precision IEEE standard. And then there are these two other things that have been showing up in particularly in machine learning. So Google is using bfloat16 because they do want more of an exponent, they want more of a range, and they don't care that much about mantissa or significant. And then now there is TF32, which basically plucks the exponent from bfloat or from FP16 and matches it with the, you know, mantissa from FP16 and puts everything together, ends up in 19 bits and just rolls on. Now, when we look at a bunch of hardware that is out there that is used for different domains, we end up with quite a bit of variety. And this is going to make everybody's life real fun. So if you target one of these, how are you going to retarget your application to target something else? So if something is running with bfloat16, will it run with TF32? Who knows? I think a lot of us are going to have a lot of fun over the time. Again, you know, some people will think about, you know, we'll see that as job security. I will keep all of this complete class, this whole class, and everyone else busy figuring this out. Now, we are not, neither Dan nor I are experts in this. We know a little bit, but we do have in our department, we do have an expert. So our, you know, not just a resident expert, but a global expert is Professor Jim Demmel. He has been in Berkeley for a while. He is a professor of mathematics and computer science, and he was our former chair. So he was a chair until a year ago, but he also participated in the revision of 754 standard, and he knows a lot about numbers. So Jim, do we hear you?
I hope so. Can you hear me?
Absolutely. Thank you.
Well, welcome, Jim, for coming. This is so great to have you here.
It's fun to be here. Tell
Thank you,
stories
Jim.
about floating point.
Very good. So can you tell us a little bit about how you ended up in Berkeley, where you came from, how you became a computer scientist and mathematician at the same time, and how did you end up loving floating point?
Well, so a brief history is I graduated from Caltech when I was 19. And then I spent 3 years working at a startup and living on Venice Beach and doing a lot of body surfing and bicycling across the country. And then I decided it was time to go back to grad school. And I only applied to Berkeley. Life was different back then. And so I started as a grad student in the math department. And Professor William Kahn, who I'll tell you more about, was my advisor. And he suggested that I move to computer science, which is where I eventually got my PhD here in 1983. And just as Professor Kahn, who's retired now, was a joint faculty member in both computer science and mathematics, after I graduated, I went and was a faculty member at NYU for a few years. And then I came back to Berkeley and I'm following his path, and I'm also in both departments. And so, but while I was his student, he had established this IEEE Floating Point Standards Committee, because the community had decided, for very good reasons, that it was just too painful to have every company building computers have different rules for how floating point work. And that's because if everybody does arithmetic slightly differently, it makes writing portable code or debugging really, really hard. And so the time was ripe to have a standard so everybody could agree. And he was the world's expert and established that standard and chaired it. And I got to work on it while I was a grad student and write a bunch of papers on that, as well as doing a bunch of linear algebra work. And then after it became a standard in 85, he won the Turing Award. That's how much recognition he got. So the Nobel Prize in Computer Science in 1989. And so while I was away in New York City, I also became part of the team that produces all the basic linear algebra software that people use, LAPACK. And so it was a great delight to be able to rely on one common arithmetic standard to write all these algorithms that everybody uses.
Sounds fun.
Yep.
And you're a department chair. So how do you become a department chair? Is that like a reward or a punishment?
So for many years, my excuse was, I can't be chair because I'm in 2 departments. I owe half my teaching to both departments. How could I be chair? But then that excuse broke down when Mike Jordan, another colleague who's in joint and 2 departments, agreed to be the chair of statistics. So I said, okay, that excuse no longer works. And so then I became chair of EECS, and it was an amazing time to be chair. There was just this, extremely rapid growth. We ended up, during my tenure with having the 2 largest majors on campus, both LNS, CS, and EECS. And we added a 3rd major, data science, which now has 900 majors signed up. So maybe we'll have the 3 largest majors on campus. And fortunately, the campus, doesn't have unbounded resources, as we all know, but they were very generous and in terms of letting us hire. And I had the pleasure of hiring 14 new faculty while I was chair. So 10 in computer science and 4 in EE. And I'm happy to say it's the most diverse crowd ever. It was half men and half women. And so a lot of those folks have joined us just recently. And so they're going to be making, you'll be seeing a lot of them in classrooms or in Zoom rooms, as you like. And on top of all that, we decided that the organization of the campus was not sufficient to deal with all of the changes in the world. And so we created a new division of data science. And we argued about the name for a long time. That's what faculty do. But the official name is now the Division of Computing, Data Science, and Society. And Jennifer Chase, formerly at Microsoft, is the new dean or associate provost of that organization. And so we're reorganizing all sorts of things in the curriculum and research and fundraising and a new building to go around that. And I'm glad that John Canny and Jeff Bokar have taken the reins to make all this work.
Excellent. And it looks like you managed to step down on time right before we got into all of this, what we are dealing right now.
Yes, yes. And I got to go back to bicycling too, which was nice. So
that's excellent news. So you're also a part of a 754 standard
right.
force.
And
so can you tell us what's new with the 2019 release?
So my first opportunity to contribute to that was when I was a grad student. And the way IEEE standards work is the rule is every 10 years, every standard has to be revisited to make sure it's still technically up to date. And so the last revision was approved in 2019. And the chair of the committee, it turned out, was another student of Professor Kahn's, David Huff. And I was a member, and a couple of my students and a lot of people from many industries and academia were in it. And so after this many years, what was worth changing? And there's always a few bug fixes, amazingly, even after 20 or 30 years. So here's one bug fix. It turns out that the way min and max were defined were not right for everybody. Why is that? I hope that Dan told people about NANs when he talked about.
I certainly did. How could you not? Yeah.
Okay, so what is the max of NAN and 3? It turns out that not everybody agrees on what the definition should be. So now there are 2 definitions of max and min.
Oh, wow.
And they're both associative because it's really important to get the same answer no matter what order you do it in. And one of them always propagates a NAN. So NAN is treated as any possible number. And in the other version of min and max, it's treated as missing data. So it's always passed over. So, and that's because that's what people wanted. But the most interesting, so there are little bug fixes, but there's one important new mathematical instruction that we added. And the motivation for this was reproducibility. And the fact that floating point, and Dan, I hope, told you about this, is not associative. If you add 3 numbers in different orders, you can get different answers because of round off.
We showed that.
And so this has become, and so it used to be, you type 8 out twice in a row, your code does the same thing. And a lot of people have depended on that for many years for debugging and for correctness. But you can't depend on that anymore because all our computers are parallel and they schedule things dynamically and you have no idea what order results come out in. And so a few years ago, there was an email to a mailing list where people share ideas about numerical software. And there was a software developer from a company who said, does anybody have some software that solves big sparse systems of equations and is guaranteed to be reproducible? Now, why did he want it? Well, he had customers who were civil engineers who did, made models of buildings and stuff. And they had customers with lawyers. And the lawyers said, every time you run your program that analyzes whether this building will fall down in an earthquake, it can't change its mind. It has to get.
That makes sense. That makes sense, yeah.
And so when I saw that, I sent email to the 100-odd Berkeley faculty on this mailing list who do large-scale simulations. And I said, did you folks know that reproducibility is dead? Is this going to be a problem for you? And most people said, how will I debug if I can't run my program again and get the same bug? There was one person who said, oh, I know better. I do error analysis. That was Professor Kahn, but there are not many people like him. And then there was one person who said, oh, the way I do my science is I do these large-scale simulations looking for really, really rare events. And when they occur, I have to reproduce them and then compute why they occurred. And if I can't reproduce them, I can't do my science. That was Professor Govinji in civil engineering. But the most interesting response was from Professor Stuart Russell, who's an AI professor in our department. And it turns out that the United Nations uses his software 24/7 to detect underground nuclear tests, which are all illegal. And so he said, well, what if my software says the North Koreans did it and then they didn't do it? That would just be a mess at the United Nations. So there's all sorts of reasons to have reproducibility. And so in the meantime, a bunch of companies have responded. So Intel has a version of their math library that slows down, but gives you, the same answer every time. But the IEEE floating point standard decided to add a new instruction that we proposed. And it's a new way to make floating point associative. And it's a very complicated algorithm, but let me just say, we had to add a new addition-like instruction that rounded differently than before. And so that's now in the standard.
Wow.
Fascinating.
That is fascinating. My goodness. Yeah.
At some point, we may have to add that to the lectures.
Yeah, no. Well, I actually wanted to ask a question from the lectures, Jim, if you don't mind.
Oh, please.
I know that there's been a fair bit of, I'm not sure controversy, but debate between Professor Kahn and Dr. John Gustafson.
Oh, I can talk about that at great length.
I know. You've probably been in those debates. I've seen some of them on YouTube.
I organized the great debate between Kahn and Gustafson.
That's right. That's right.
At the Computer Arithmetic Conference a few years ago, yes.
Right. And I think it was taped on YouTube. I watched it. It was fascinating to watch. Can you share your perspective on a Unum? I mean, he claims a Unum to a float is what a float is to a fixed point. So let's have the final word on that.
So let me start with just a little bit of ancient history. When floating point numbers were first proposed as an idea, von Neumann thought they were a bad idea.
Oh.
And that's because he said anybody who's competent using a computer should know what dynamic range their numbers are in and scale them all to fit in fixed point, to fit in integers.
Right.
So floating point is, for people who aren't competent. But, but floating point 1, obviously, because it's much easier to program and all of that. All of that.
Yeah.
So many floating point formats have been invented and reinvented over the years. And Unums have the property that they have variable precision. So they can use more bits or fewer bits for the exponent, depending on how big the exponent has to be. And so numbers near 1 have lots more manticipits and are more accurate. And numbers that are really large or really small have less precision. So the first time this appeared it was actually a homework problem in Knuth Volume 2. He said,
I did not.
He asked, could you invent this? And the first proposed solution was published in 1971 to do this. And then it sort of, nobody paid attention. And then it was reinvented again in the 80s. And in 1987, I wrote a paper which explained how it would mess up error analysis of all the standard algorithms. So anyway, Gustafson decided to reinvent it. But I think the thing that really made it people object was it was variable length. So every number could have a different length depending on how many exponent and manticipits it had. And so that means, how could you have an array? If you have a 100 by 100 array, where is A sub 100, 100? You have no idea, right?
Right.
So the whole goal of saving memory, which is Gustafson's goal, doesn't work. So anyway, he decided to go back to the drawing board, and he invented something called posits. And that came out a few years ago. And those are also variable precision, but it's fixed length, fixed number of bits. And so there's been several groups who've been pushing it. But let me just say, I don't think it's a good idea. I have on my webpage a link to a paper by some experts, and the name of the paper is Posits: The Good, the Bad, and the Ugly. And so, so they talk about all the things that can go wrong too, but from the error analysis point of view, making software correct, it's just painful when numbers have different precisions depending on whether they're large or small or close to 1 or whatever.
Right.
And the other thing that's missing from posits, it doesn't have nands. And so if you divide 0 by 0, Gustafson said, oh, you should just stop because your code's obviously wrong. But this just makes writing reliable code a little too hard.
Right.
Yeah. One comment about that. RISC-V is open, and anybody could invent an extension. So this has been coming up multiple times by Gustafson and others. Can we get a posits extension for RISC-V? And they keep showing interest in that.
Well, I had emails from Dave Patterson about that last weekend, and he wanted to know what are the arguments pro and con. So I sent him a link to the good, the bad, and the ugly.
Yeah.
Very good. But that's the beauty of RISC-V. It's completely democratic. You can do whatever you want to do it, including adding posits if it suits you well.
So you made the point that there are a lot of new formats being proposed, not just unums and posits.
Yeah.
bfloat16, all these different things. And there was a paper just from a couple of years ago called ternary arithmetic, where there are only 3 numbers, +1, -1, and 0. So, so it's wasting, it uses 2 bits, of course, so it's wasting one of the patterns, but there's a bunch of evidence that that's good enough for training neural nets. All you need to know is, do you go up, do you go down, or you not change?
Interesting.
And so there is no one format that's going to make everybody happy. And it's a little bit of the Wild West right now.
Right.
But I think it's fair to say that not one format will make everybody happy.
But
makes sense.
Final thoughts. So FlexPoint is kind of a distant relative of
Yeah. So that was from Nirvana. And just to tell a little side story on Nirvana, I was teaching 267, CS267, my parallel computing class. This was a few years ago, and I was teaching a new algorithm for multiplying matrices. That could go, much faster than the previous ones. And one of the students in the class thought it was a good idea, and he founded Nirvana, Amir Khosrowshahi. And so I was an advisor, for that particular aspect of the work, but not for FlexPoint. So just as I mentioned, everything is invented more than once. So the old name for FlexPoint is block floating point, and it appeared in a 1963 book on error analysis by Jim Wilkinson, who won the Turing Award in 1970 for his work in that stuff. So the idea has been around for a while, and it has its pros and cons. But again, it puts a lot more burden on the programmer to figure out, which numbers can I put together because they share a common exponent without losing too much precision. And it sort of goes back to Von Neumann, who said, "Oh, we should all scale stuff and use integers, versus let's make it easy to program." Life is trade-offs.
Wonderful.
Thank you. So one final thought, and then we'll let you do whatever you need to do. So how are we going to handle all of these DF32s and bfloats and all IEEE?
Well, actually,
it's a soup. Yeah. How do we handle the soup?
Well, all right. So we have a grant to keep maintaining, LAPACK and ScalaPack, these, the linear algebra libraries that everybody uses. And one of the projects that we're doing is to ask, do these standard linear algebra algorithms work in bfloat16? And so I proposed this, sort of half as a joke, as a class project in my Math 221 class this semester, and a student said, "Oh, I want to do that." So what we're planning to do is port all of LAPACK to bfloat16, and LAPACK comes with all this test code to see whether it's correct or not, and we're going to see whether it passes or fails all the tests.
Interesting.
And so in the meantime, though, a lot of people are proposing mixed precision, where you try to do a lot of the work in low precision, say half precision, and then you do a little bit of extra work at the end to clean up the answer, and by doing it in higher precision. And there's a bunch of algorithms been around for a while that work for some well-known problems. Basically, you solve the problem and do a few steps of Newton's method to sort of clean it up.
Yeah.
And for some problems, that's cheap, and for some problems, it's pretty expensive. So it kind of depends.
It's like how I play golf. You hit a big shot, you get a rough thing, and then when you're on the green, you putt in the higher resolution. So that kind of makes sense. I like it. Yeah. Nice.
Yeah, that's the claim for A100, so that you should be able to do multi-resolution.
So maybe a lesson for the students is that you have to understand a little bit of enough math to understand where the errors can be, so you're not surprised badly.
All right, thank you, Jim. And I believe you're teaching CS70 next semester. So
actually, I just got changed to 170.
Oh,
170.
Perfect.
Oh, congratulations.
Yes, it is.
Yeah, so Alessandro Chiesa and I will be teaching 170 together.
Wonderful.
All right,
Wonderful.
so
great.
I think people may, some of the students may take 170 next
Yeah,
semester.
may have you in their classes this coming spring.
that
That would be
fun.
wonderful. That'd be
All
great.
right.
Okay,
All
well,
right.
it was wonderful
Thank
being
you
here.
very much.
Thank you so much,
you.
Jim, for what you've done for the
Thanks,
department
Jim.
and for joining us today. Thank you so
Okay,
much.
take care. Bye-bye.
Wonderful.
Thanks, bye.
Take care. That's great.
We have a
All
few more
right.
items.
Yep.
We have two kind of polls to run. I think I'll hand them over to Dan. The first one,
Sure.
I don't know how to start them, but I'll first give the introduction for the first one. We have been thinking about how do we do this, how do we do the clicker questions, right? Because we do want to keep everybody on track, but we are trying this time not to keep everybody on a really too tight of a leash. We really need everybody to stay on track with the lectures such that we can proceed with homeworks and we can do the labs, and they're all, whole complete learning experience. So how do people feel? So I'll hand it over to Dan about how do we administer these clicker questions.
Sure.
We are on
So
iteration number 3 now.
Yeah, we're trying to optimize. This is all new for us. We want to basically be responding to what you'd like to see. And we want to have a little bit of time as well to talk about how to do the exam. So we'll talk about that first. But the first question is, these lectures, sometimes they come in single one lecture pieces, which we slice up into mini pieces. That's what I did for Floating Point. And by the way, that did grow a little bit longer than 50 minutes, and that's okay because some lectures will grow smaller than 50 minutes. So it'll work out to be just about right. We're not going to double load you in terms of lecture, but this floating was a little extra because I wanted to show you a little demo at the end of it. So that's an easy one. That one was due there. But then we said, do we have it due every single Monday, Wednesday, Friday to keep you up like this? Or do we say, let's try to do it once a week as a compromise of that? And different people might...
Tuesday, Thursday, Saturdays when it's due.
Right, exactly. Should they be due Tuesday, Thursdays, and Saturdays, or just kind of do Thursdays, and you have to do every other thing from last week up to every Thursday? So that's kind of how we're doing it. And if there's any strong preference either way, you can do it. And if, by the way, you would have preferred it Monday, Wednesday, Friday, we'll try to have it up in advance so that you could actually go ahead and do those things. So that should work as well. That's the first part. So thank you for that feedback. It looks like people are really split on that. I'm looking at the numbers here in the poll. The poll looks like
this was not tremendous help.
This is, yeah, they're all around the board. Every single bucket is there in the thing. It's a very funny thing.
Just so you know, I mean, every single, all of us, including TAs, had some opinions about how to do this.
Right. And some of that's borne out by data. We actually surveyed the folks last summer, and the folks last summer said almost overwhelmingly that they would be falling behind if it weren't for us keeping them up to pace every Monday, Wednesday, Friday, like a heartbeat. Summer does run a little bit faster than spring and fall, but still, that was very useful to have that as a part of our conversation. Part two is we wanted to allow for you to have an asynchronous model. That was the first pass. The first draft is let's have them be asynchronous. Let's give them a whole day. They can wake up Sunday morning and then have a nice breakfast and pull out the exam. The exam is going to be broken up into questions, and every question will be a time where you jump in, you're you're locked in, and you can't stop. You can't take a break mid-question, and then you got to freeze it. And hopefully that question doesn't take you more than 20 or 30 minutes, so hopefully you can give a good 23 minutes, big stretch, and then go take a stretch, and then walk around and have some food, hit the restroom, and then come on back again. So that's the model. That was going to be the model. Many people have shared on Piazza that there's a concern about how to do the time lapse. We were thinking if you need to have some way to verify people are just keeping it copacetic, having a nice thing and they're not going on Google and not their friends. So how do you do this without the onerous? And we've heard a lot of negative comments about synchronous Zoom proctoring being really hard for people in different time zones. And what happens if the thing goes down? And you're watching, blah, blah, blah. People are watching. They're seeing your room. What if your parents come in, or if you're so that's a concern. So we wanted to basically allow people to have an ace. And by the way, synchronous means you and the staff have to be on the same computer at the same time for some amount of time. And you have to kind of limit what that time is. Unlike the asynchronous model, which says, just go home and take it for 24 hours. If you want to work for 20 hours, that's great. You want to work for 2 hours, you work for 30 minutes, that's fine. It's just more relaxed in the asynchronous model. But we do understand that some people are worried about their phones not being able to do a time-lapse video. We did do a test, and we found that the test and remember, we don't expect people to really, because we're going to break this up into pieces. You'll do one piece, that's 20 minutes. So people, it may not be that much work on your phone in terms of the amount of storage you need and the amount of actual, overheating your phone might do, because you're not going to be there probably for an hour. You'll be in for a set of small questions and then stop and then break and then come back in. So it may not be, and for each one of those, we're going to need a time-lapse video as well. So that was the initial model. But some folks said, well, we can't actually do that because my phone doesn't have a time lapse, and nobody in my family has a time lapse, and I have no access to a time lapse phone that'll do that. So how do I do that? So Bora, I want to give Bora the props for thinking of this. He said, well, what if we allowed for a backup with Zoom proctoring? So that means we know people usually don't like Zoom proctoring. Usually, although I'm looking at the survey, and the survey is equal preference for Zoom proctoring and equal preference without Zoom proctoring. So that the idea is for people who don't have access to that, you would be able to get online, and we're going to only, maybe have one time where you have to get in there, and it's going to be a fixed time. We're going to be there. You have to lock in. We have to start at the same time, and it's not, that whole flexibility is gone. You're in there you're in there stuck, and we have to watch you, and you're watching your thing, and you're watching the screen, and we've got the whole situation. And in that situation, your camera has got to show your whole, we have to then have a conversation maybe on our side of how we get the screen and you and your desktop and how all of that together. If we do Zoom proctoring, you have to then have your camera above. Maybe you have to have your camera as the Zoom camera showing both the screen and the desktop so we can see the screen, because you obviously could have another window open with some bad stuff. So we need to be able to see what's on your screen, and we didn't want to have a time lapse of both the screen. So we didn't want to have both Zoom proctoring and a screen recording. We'd like to be able to have just one movie for each of these things, or a live Zoom that is able to see the whole desktop. So this is a concern. This is where we're working with this. Fortunately, this quest is not worth that many points. So it's not like, well, this is worth 90% of your grade. This is worth a very small amount of your points. And we're going to try, I think we might have to try both, because I'm hearing that enough people cannot do the time lapse that we have to be able to give a little bit. So I want to be able to have some questions and concerns. Bo, you want to jump in?
Yeah, there are some good questions that came through the chat. I don't know if I'm paying too much attention. Stephen, if you see some, maybe you can read a few. There are comments over there that I think some people didn't realize that if it is a Zoom proctor, that it's going to be a fixed time. We are not going to be proctoring 24-hour.
Correct.
Dan and I are not going to be sitting in front of screens for 24 hours.
Right. So we almost want to encourage people to take the advantage of the asynchronous, do it whenever you're comfortable time-lapse model, if that works. And encouraging people, if they can't, if you really prefer to just the way you work, or because of technical reasons you really need to go with the Zoom proctor, we're going to have to find the time for our staff and us to be there. And it'll be on Sunday, so we'll both be on Piazza answering questions, and we'll have the official exam starts here and official exam ends there, and it'll be the same idea. Either way, by the way, each person's going to get hopefully a randomized exam, and so your exam should be different than your neighbor's exam, and you'll be doing it and we'll be able to watch you and be able to answer any questions. So it's not like you'll get more support if you're Zoom. You're going to be here's the thing about the Zoom proctoring. You're going to have your camera on. Again, that's a privacy concern, which is why we wanted to not have that as the default. And your microphone has to be on. Both of those have to be on. So we're hearing what's room. You can't have people in the room doing that. So that's very different. You have to be on a fixed time with the camera microphone on, but your speakers are off. So you're not hearing so if someone coughing, you don't want to hear everyone coughing in this room, but essentially it is like we're all watching you at the same time like that. It's not any different. So I hope that, I don't know if that affects people's votes, but that's what the space of that Zoom proctoring situation is going to be. And it's a lot more, we have to now manage 2 of these exams to do this. But most people in the summer did not want to have Zoom proctoring, and most people were doing that. So this is only as a backup for people who don't want to have, for whatever reason, the time-lapse technical reasons or their own, the way they study. So
yeah, there is a question that I saw multiple times, what time
yes, everyone's in the same room. That's the idea.
No, the time lapse. It's like there is a standard setting in iPhone. If you have an iPhone, it's like takes a picture of you every 5 seconds.
That's correct.
You want a picture of you from behind your back and your screen, and that's it. And it's not a very big file, but if you don't have an iPhone, then you have to have an app on Android that would do that.
And we have a policy in this class, which is unlike every other policy, which is our exams clobber. So if you do better in your midterm than your quest, then that'll be the way. So because of this clobber possibility, you don't also need a tripod. You can have anything that can, a box, anything that can place your camera above and behind you so it sees your screen and your desktop. Literally an Amazon box. Tape it to the wall. Like literally you could sit with your back against the wall, put it on a windowsill. I just responded on Piazza about that. But if you decide to go to the Zoom, you're all in the same Zoom meeting. Everyone, microphone and camera must be on, but your speakers are off, so you can't hear anything. You're just delivering the data to us, and we're watching the whole room and capturing it on recording. So we have that there. But no one's able to, and you're able to see everybody else. That's the part of this, the privacy thing. You have to find a quiet space that you can do that, and that's a lot harder.
We thought that this was a lot easier, a lot more flexible, because you can do it. You know, do a couple of questions, go visit the refrigerator, do whatever you need to
exactly.
do. And
we thought that the students would just eat it up. They would just say, "Oh, thank you so much." But enough people are like, "Wait, blah 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 blah, technical. Yeah, I don't have a box. I don't have a thing. I'd rather be in the Zoom. Just make it easy." All right, well, we'll give you that option too. So that was Bora's great idea, and I think we'll support that as well. And we'll have to decide very quickly what time that'll be, and let you know. It'll be Sunday, so it's 4 days away. But we'll let you know, as well as revealing, sharing the official document about the logistics of, here are 10 different ways to put your camera above your shoulder. Here's a box. Here's a tape on a wall. Here's sitting behind a windowsill. Here's that kind of thing. So we'll have to do, here's my neighbor holding it up. No, but here's my neighbor holding it up for an hour, above my thing. So that's the place of that. Happy to try to talk to more. This is the chance for Q&A. This is the Ask Me Anything situation.
Both of us.
Yeah, anybody.
Let's see the questions actually.
They're in the chat.
Q&A. So Stephen, if you see them, they're also in Q&A, and it's hard to follow all of this.
Yeah,
Stephen,
I got a lot here.
Go.
I got a lot here.
And
Zoom proctoring, you cannot disconnect audio. I'll click on that one. You'll have to have your audio on and your video on both. And so we're hearing sound from every room, and we can mute you. So we can mute you and unmute you, but you'll have to have that on. So if someone were kind of whispering over your shoulder, telling you the answer, we'd know that. That's the idea. So that's that one.
There's a question about, is the Quest digital only? Will it require submitting any paperwork? Currently, no. You will not need to submit any paperwork.
No paperwork, exactly. No paperwork. And CS70 had a whole policy about you print the paper and you work on paper. None of this is there. You get a randomized exam, as I think 70 did as well, or to try to at least. And then, so everybody's a randomized exam as much as we can. You give randomization, and it's all digital. You're all going to be in the system called Prairie Learn. And here's the important thing. We're going to have a practiced quest that's going to be released very, very soon if it's not already released. Stephen, do you have a sense of ETA for that at all?
I don't know, because CC's the one who's been.
Okay, so yeah, but it's going to be very soon. We're going to have a practice exam, which means, and by the way, in the practice exam, I would encourage everyone, every single person, to try to put their phone above them and try to do this and put it on for an hour. I don't think it's going to take any of the sub questions an hour, but try it. Give that kind of a high water mark. Put your phone above you, try to capture that and get a sense. And we'll also try to share as much as we can examples. We're going to have this, again, the Quest Logistics doc that'll have all the examples of that, because it's going to be a real pain for folks to have to do Zoom proctoring if everybody has to get on the same time zone. So the more people that can do this asynchronous thing, we think it gives you, by the way, the Zoom proctoring, we're going to have a finite time, maybe double time. So we'll have 2 hours we're going to sit with you to do that. But you'll have 24 hours if you do the time lapse. That's the other difference, is you can take a rest. And obviously not going to ask you 24 hours to work. Probably it's going to be, we think it's going to be less than an hour. That's what we think. We're going to try to have the exam that's doable in less than an hour. That's what we always try to do. So that's the idea.
Yeah, and again, nobody has administered an exam like this to 1,200 people.
Right.
So we are trying our best.
Right. And by the way, I should add, somebody just had an interesting point, which is you could do Zoom if you have a second computer. If you have a second computer, that computer behind you could be your thing. So if you wanted to Zoom from a second device, you could Zoom record. If you can record that, you can record that. It doesn't have to be time-lapse. If it's actually the full video, that's fine. It'll be a bigger data file, but we can live with that too. So if you have something else to record you, like if you have a GoPro or a second computer doing Zoom, you could do that. The problem is the normal Zoom is only from out the computer. We need to see your desk space. We need to see what you're going. We need to see your screen, and the Zoom wouldn't be able to do that.
You can do it from an Android phone. You can just call into from a Zoom app and
right.
do it.
So
do the cloud recording.
Yeah, that you could do that if you wanted to do that. So there are ways to be creative about this, and hopefully we'll add this to all these logistics stuff. We're trying to support everybody in this kind of new space, but again, we're trying to be as flexible as we can for everybody. I'm at 5:01. I want to make sure. So Zoom proctoring. Okay, disconnect audio. No, you cannot. Again, the camera is going to be showing. So I'm answering this one live. The camera is going to be showing your desk, your hands, and your screen. That's the most important thing. Okay, so we see, so on our tape, and by the way, usually these things are high resolution because they're just a picture every time, not a whole full movie, but it's a full picture. So we can actually be able to read your screen and see what you're doing for every single frame. We'll be able to start to go through that. And it's a smaller file format, so that's there. Asynchronous can do Zoom. Yes, you can. And I answered that live because you could use from a second computer for that. A lot of questions, boy.
Yeah.
I'll do the answer. There is no time limit when you start the exam if you do the asynchronous model. You can start and stop whenever you want to. You just have to you cannot start and stop within a question. You do one question, you cannot start and stop, and that question should be about 30 minutes max for each of the small parts. I think probably 10 minutes for some of them, 5 minutes for some people. Done, to go take a break. So you can't stop once you started a question, but then you can take as much break as you can for that. So there's no time limit, 24 hours to do all the whatever parts we have. I think it's like 3 or 4 or maybe 5 parts we have to the exam.
So one question that I can take about these due dates, right?
Yeah.
I mean, we have had among ourselves the debate. There are different people who have different learning styles. So, it may work fine if everybody, if we have everybody watch every lecture when it's supposed to be Monday, Wednesday, Friday. But some people may prefer to watch 2 or 3 as long as they're not falling behind and they're ready for the labs and homeworks and so on. So we're trying to accommodate that. We made a due date on Thursday for 2 reasons. First, honestly, if you look at RISC-V lectures, they're not 3 times 50 minutes, they're less. And you should be able to, there's slightly more than 2 50-minute slots that are in there. Even though I've thrown extra stuff in there, I still wrap it up in less than 3 times, 150 minutes. I'm done in 120 minutes, about 2 hours total. But we would like you to be ready for the labs that are on Wednesday, Thursday, and Friday. And that's the big goal. That's what we are trying to set. So we can try to adjust, we'll try to see what we can do with that. Should we, capture, there is a strong preference now, I think, to go for, 3 times a week, 2 days for due dates for clickers. But the option for that perhaps maybe to go Friday, Monday, Wednesday, and then make sure that everybody is done by Wednesday and ready for the labs that week. And we can try to adjust to that.
Actually, there's a quick question. Is a proposal, could you possibly do the Zoom recording for the time lapse on the device you're taking the test on? And the answer is no, because we kind of have to make sure your hands and your phone and everything is clear. So it's like the model is the time lapse covers your space, your workspace, your desktop, your phone, your what computer you're using. If you only record the screen, then you could be on your phone texting your friends, and that's not cool. We basically try to reduce all the kind of outside ways. We're trying to lock the house and prevent all the outside kind of obvious ways for this, and that's the reason we have the phone over the shoulder situation. So you can't do that one.
Dan, what about if they have multiple monitors?
I'm actually okay as long as this camera can see the multiple monitors. I mean, if you want to be able to have, by the way, we're going to ask you to do some C programming in the exam, the practice exam. Oh, this is very important, but boy, this is really crucial. The practice exam is just to practice with Prairie Learn. The practice exam is not to simulate exactly the difficulty or exactly the topics that are on the exam. So there is a floating point question on the practice exam. Do not panic. There's not floating point on the quest. Okay, so that's just to give you, just to throw you out kind of the kind of questions that, how do you answer? One's a multiple choice, one's a fill in the blank. We threw a floating point in there because we had it in our back pocket, but it's not on the quest. So do note that the practice exam is, and we're going to send it out there very soon, is going to be not exactly the model or the difficulty of what the question be. Don't come to me and say, hey, the practice exam was too easy compared to, yes, it's much easier. We're just throwing some basic baby questions out there that are not just trivial, what color is the sky, but actually maybe some learning that happens in there with a thing. But we threw floating point in there because we had it in our back pocket, but floating point is not on the exam. So it's not a model of the difficulty, but it is a model of kind of how you interact with the system. And you should please do that before Sunday so you can practice it. Yes.
To finish on a light note, we are not asking to calculate Avogadro's number from the color of the sky. You know how to do that, right? 6 point something, 6.023 to the power of 10 to the power of 23rd.
23, right?
Calculate that from the color of the sky. Perhaps not today because there are too many colors in the sky, but on a clear day, you totally can.
Right. It actually got brighter. Like, I can't believe that it's 5 o'clock and it's brighter. You know why it's brighter, by the way? Do you know why? Because here's the cloud layer, here's the sun up here, and now the sun is and now it's hitting from a skew angle, so it's cutting under it. So it's actually being measured brighter at 5 o'clock than it is at noon. Unbelievable. That's it. We'll try to answer more questions on Piazza. We're going to launch the practice quest. We'll have the logistic exam. Any last thoughts, Stephen?
There was one more important one. Is the quest open book? Can we have lecture slides, textbooks open on our computer?
You can have, the answer is yes. You just cannot do Google searches. You can't ask your friends, and you can't do Stack Overflow, but anything we've given you, it's all open book. Anything we've given you, you can use. You can use a book, pull the book out. Anything we've given you or anything from a resource book, but you just can't search on the web. That's the idea.
This is a big difference from past.
Yeah, very different, by the way. And this would be true, but this would be true for either model. Whether you decide to go asynchronous or Zoom proctored, that same policy of being open book to be for everybody. That makes sense. All right. Good stuff. Well, we're late for our 5 o'clock meeting, Bora. Thanks, everybody. We hope this we hope this helped. Good to see everybody. We'll see you next.
See you soon.
There is a question, before we close it, there is a question about what happened to the group tutoring. My group tutoring is on Wednesday. My individual is on Friday. Bora's individual Wednesday, group is on Friday. So on Friday, Bora will be having his group tutoring, I believe. Bora, you can give the thumbs up to that or not?
Well, let's try to organize that. So we can probably, it's very close to the quest. So we will just talk about that now, and we'll let you guys know how we're going to run
perfect.
a series of review sessions, so topical review sessions, such that
that makes sense.
Compressed version of what we have done so far.
Perfect. Good stuff. Thanks, everybody. Good to see you all. Take care. And we recorded it successfully. We did this. All right. We remembered. Thanks, Stephen.